As we know that Newton's laws of motion are the fundamentals of the dynamics portion, in which we will not only discuss motion by a geometrical point of view, we will discuss motion by analyzing the cause behind the changing motion. That is called force. The effect of force is considered in Newton's laws of motion, which was not considered into the kinematics portion. Whenever we discuss kinematics, we discuss about those quantities like speed of a particle, velocity of a particle, acceleration, retardation, distance traveled, displacement, all these things. But we never discussed what causes a particle to move in this manner or in different path. Suppose a particle is moving along a straight line. These fan blades are moving in a circle. A particle thrown horizontally cannot follow the straight line path and eventually fall in a parabolic path like projectile motion. So why these different types of trajectories will occur? Which type of cause is there for this type of different types of motion that we haven't discussed in kinematics? What we discuss in kinematics? Under the action of something, some acceleration is occurred, and on the basis of that acceleration, we try to define the trajectory. But if we know force, then we can predict what will be the subsequent trajectory of the motion in future. Because in kinematics, first the motion has to occur in front of your eye, then you see the motion and describe the motion. But in dynamics portion, before the motion occurs, you can predict what will be the subsequent motion in future if you know the force acting on the particle and its initial position and initial velocity. That is the main essence of Newton's second law of motion. Now, while we are discussing the concept of force and all these things, first we have to know that where the observer is and what he have with him. First, the observer must be in an inertial frame. So, it's easily speaking, inertial frame, you can consider some reference frame where there is no acceleration of the frame. Frame is itself not accelerated. Means the observer is either at rest or moving with uniform velocity. He has no acceleration. Right? Now, then we can apply Newton's laws of motion to predict all these things. Dynamics of the particle. Now the question arises, inertial frame. How can we recognize inertial frame? Inertial frame can be recognized by verifying whether Newton's first law is true or not. What Newton's first law says? A body at rest will remain at rest, or a body in uniform velocity will continue to move with uniform velocity unless it is acted upon by an external force. So in absence of external force, there will be no acceleration of a body. And if that is verified, then it is called an inertial frame. So in which reference frame observer says that, okay, there is some acceleration of a body and definitely some real force is responsible for that. So my frame is inertial. And if in some frame observer finds that body is accelerating but he can't find any real force acting on it, he will immediately call that his frame is non-inertial. And then he will take the pseudo forces and all these things for explanation of that law. Now, most of the time when we discuss mechanics problem, we consider earth as a reference frame. Because we are standing on the earth, we are sitting on the earth, and all these things are related to the earth. But truly speaking, earth is not an inertial frame. Because earth has acceleration. Because it is rolling, it is rotating about its own axis and revolving around the sun. So there must be some centripetal acceleration of the earth towards the center of this curve, and there is another type of acceleration of the earth you learn in geography, Coriolis acceleration, for which the sea current and all these things are changing the direction in northern hemisphere and in southern hemisphere. So these accelerations are present. So earth has some acceleration, so it is not the acceleration due to gravity, it is due to the rotation and revolution of the earth. So strictly speaking, earth cannot be an inertial frame because it has acceleration, but we can consider earth as an inertial frame for applying Newton's law for the daily life mechanics problems, because these accelerations are very small compared to the acceleration of the bus, acceleration of the plane, acceleration of the block, etc. So we can neglect, and for our purpose we can consider earth as the inertial frame. Okay. Now, Newton's first law is not giving you any mathematical formulation, it only gives you a concept of the inertial frame. Now, for the mathematical calculation, we have another second law, that is called Newton's second law, that is force equal to mass into acceleration. You know, when applied for a body of constant mass, because suppose a situation is there, a water bottle, suppose this one, water is leaking from the water bottle. Now this water bottle is thrown, it is acted upon by gravity, but we cannot apply Newton's law in this format, F equal to ma for this, because water is continuously falling from the bottle, so total mass is changing. So in this situation, F equal to ma, this format is not applicable. So we have to consider the other format of the Newton's law, second law, that is the general format in terms of the momentum. Okay, now one crucial point comes after the discussion of the first law. Now when we are discussing first law, you find a term linear momentum. You have heard about it, linear momentum. And second law says that rate of change of linear momentum is directly proportional to the applied force. This is Newton's second law statement. Rate of change of linear momentum is directly proportional to the applied force. Now just think about it. What is momentum? Momentum is mass into velocity. Okay. This mass into velocity means it has some dynamical property. Body at rest has no momentum because velocity is zero, so momentum is zero. So it is some dynamical property of a body. Now think about it, what Newton says. Rate of change of momentum is directly proportional to the applied force on a body. So F proportional to dP dt. Then Newton was claiming that for the measurement of the force, you have to know the rate of change of a defined quantity called momentum. But before Newton's law, in kinematics, whenever we discuss, there is no concept of momentum. Now, what is momentum? Product of mass and velocity. Now, how Newton realized that for the calculation of the moment force, product of mass and velocities are required? How Newton think about it? Out of nothing, he multiply mass with velocity and calculate and find a new physical quantity and say that this is required for measuring the force. So can we multiply any two physical quantities to find a new physical quantity? It is not possible. Now how Newton realized that? Just think about it. Why particularly product of mass and velocity? So many things are already available in kinematics. From that, can you It is not possible for the Newton. Is it not possible for the Newton to calculate force? Why he prepare a new quantity by multiplying mass and velocity? Acceleration is also dynamical property. Okay. See. Achha, how many of you know about Galileo's experiment from the Leaning Tower of Pisa? Galileo performed one experiment from the Leaning Tower of Pisa. In Italy's Pisa, there is a tower which is some bent called the Leaning Tower of Pisa. Galileo find one experiment, but before that, and the Aristotle's times, it was generally believed that when a heavier object and a lighter object are dropped, heavier object will fall first, lighter object will fall later. Means it falls with more velocity, it falls with lower velocity, and that's why it takes more time to come down. But this was actually wrong concept. Galileo proved from the Leaning Tower of Pisa by dropping different objects that if it is vacuum or close to vacuum, because Leaning Tower of Pisa is not, whenever you are dropping, it is not completely vacuum, there is air. So in that situation, if we consider and prepare a situation where there is complete vacuum, all objects of different masses will fall with equal velocity and they take equal time to reach to the ground to cover the same distance. So a coin and this water bottle, both will fall, if they are released, both will fall with equal velocity, always. It is not that heavier mass will fall with more velocity. This is Galileo's experiment. Now, any one of you come here. Heavier mass and lighter mass, according to Galileo's experiment, fall with equal velocity. Okay, I will drop this one over his hand from this side. Now I want to drop this one over his hand from the same height. So both will move with same velocity. So force applied on his hand will be same in both the cases. So I must drop. Why not? In which case force will be more? Second case, because mass will be more. So though velocities are same, mass is more, means applied force will be more. So which determines the applied force on his hand? Mass or velocity? Mass. When velocity of both the object remain same. Now the second case. Okay, fine. Now, I prepared the mass is same, assume, this mass. First one, this mass is striking his hand. It will apply some force. Next time, same mass, but which case apply more force? Second case, when it is going with high velocity. So now if masses are equal, then which quantity determines the amount of force? Velocity. So, but neither mass nor velocity can independently measure force. What can measure? When product is maximum. See, in which situation force will be measured? If this one is with high velocity hitting this one. So, in that case, mass is more, velocity is more, so their product will be more. So, it will apply maximum force. That's why Newton realized that only mass or only velocity is not sufficient to measure the amount of force. It is the product of mass and velocity which can determine the amount of force. That's why Newton prepared a new physical quantity called momentum by multiplying mass and velocity. Clear? Is it clear to everyone why momentum is so important in measuring force? Okay? Now, another thing is that Suppose this mass is thrown with a certain velocity, and when I am taking the catch of this mass, I pull my hand little bit backward, and another person is there who is not willing to pull it that much backward. He will stay his hand over here and it tries to catch. Who will feel more force in his hand? The man who will stay his hand over here, because it is coming with a certain velocity, means it has mass into velocity, means momentum, and its momentum immediately comes to rest. And if I am allowing certain distance or that is certain time, then its momentum goes to zero within large time. Then the rate of change of momentum is more in the first case because time is less. That's why force is measured by rate of change of momentum. See the relation? If changing momentum is more, force will be more. If changing time is less, force will be more, because these are inversely proportional to the time. With momentum, force is directly proportional. With time, force is inversely proportional. Clear? Now we can write from here F equal to some constant K d dt of m into v, mass into velocity. Okay. Now, if you define the unit of force, that is, if a force of 1 Newton acts on a body of mass 1 kg, it produces an acceleration of 1 meter per second square. Then K will be 1. Then by defining K equal to 1, we can write this one will be F equal to, I consider first the mass constant, it will become dV dt, which can be written as F equal to m. Force equal to mass into acceleration. That is only valid if mass is constant, because in this derivative I consider mass constant, so mass can be taken out, only dV dt will come, that is the rate of change of velocity with respect to time, which is called acceleration. Clear? Is it clear? Last page. Now, this one is the second law of motion for constant masses. If there is variable mass, then we will calculate this derivative by using the product rule. M dV dt, another term will be there, V dV. That we will do for rocket motion and all these things. Now, comes to the third law. I think all of you know what is third law. To every action there is an equal and opposite reaction. That is only valid for the real forces. Again, you must be in inertial frame. For pseudo forces, this action reaction will not be valid. Now, there is a common misconception that action and reactions are equal and opposite and they will cancel each other to produce zero force on a body. That is not true. Because if action acts on body 1, reaction acts on body 2. So both bodies are subjected to a single force in opposite direction. So net force on a single body is not zero due to action and reaction. So action and reaction can never cancel each other. Okay. Suppose these two markers, these are thrown, they will collide, and during collision, this black marker will apply a force on this blue marker, and blue marker will also apply a force on the black marker. So how many forces are acting on the black marker? Only one, given by blue marker along this direction. So it will move along this direction with accelerating. The blue marker is fielding a force given by black marker in this direction, so it will move in this direction. It is not that both the forces are acting on the same body and they will be at rest. So action and reaction cannot produce equilibrium since they are acting on different objects. Always remember, whenever you draw the free body diagram, don't draw action and reaction on the same body. Then it will be a mistake. Clear? So write it. Action and reaction are acting on different bodies. We have to remember this one when drawing free body diagram. When drawing free body diagram. Okay. Action and reactions are equal, acting on different bodies. So when we are drawing free body diagram, we have to remember this one. Now, as of now, our theoretical part of the Newton's law is almost complete. Remaining part is different types of problem solving, free body diagram and identifying the forces. Now, how many forces generally we deal in Newton's law? Because all are essentially, all ideas are going around this term force. And this force, is it a single force or it is many forces sum?
Many forces.
Many forces sum. Whatever be the external forces acting on the particle, suppose 5 forces are acting on the particle, 5 external real forces. Their vector sum is that F. Suppose weight can act on a body, friction can act on a body, normal reaction can act on a body, tension can act on a body. You may pull it with some force. So all this buoyant force can act on a body. All these forces, whatever is acting on the body, its vector sum is that F. That is equated to mass into acceleration. Now if someone asks you, what is Ma? What will you say? Force. Now I am asking, what is the origin of Ma? You cannot say. But if I am saying that F is W plus friction plus normal reaction, all these things, plus tension. Suppose in a problem all these forces are there, I add them using the vector symbol. Then I can say that what is the origin of W? It is Earth's gravitational pull. What is the origin of friction? The two surfaces applying a force to oppose the relative motion, that is the cause of friction. What is normal reaction? The body is on certain surface and surface is applying an upward push on the body, that is called normal reaction. What is tension? Body might be attached with a body may be attached with a string and string is pulling it with a force tension. Now I am asking, what is the origin of Ma? You are saying it is force, but you cannot see. Ma is equal to the resultant force. It is not a force. The sum of all the resultant of all the forces is measured in Newton's second law by the product of mass and acceleration. It is not a real force given by some external agent. So always remember, left side of the Newton's law, F is the resultant of all the external real forces. External real forces. Okay? And right side is equal to mass into acceleration, which is equal to sum of the external forces, real forces. Ma is not a real force given by some external agent. Because most of the time students write that Ma is a force, Ma is not a force. Ma is just equal to the resultant of all the forces acting on the body. Clear? Now, you probably learned this word line that force is the cause of motion. So if force is cause of motion, then this cause may produce some effect. What is that effect? This effect is this acceleration. Force is cause, acceleration is the effect. So that's why don't say any time that ma is a force, because it is the effect of the force. All the forces are here on the left side. It may be weight, it may be friction, it may be normal reaction, it may be tension, and many others, maybe electrostatic force and all these things. And all of these forces together will produce some effect. That is measured by mass into acceleration. So ma is by no means a force. Its mass product is equivalent to all the forces effect. Clear? Okay. Now we will discuss about the properties of these forces in a problem. Suppose I consider three forces on a particle. This one is F1, this one is F2, this one is F3. The mass of the particle is m. The question, first draw this diagram. What you have learned in triangle law, that two sides taken in same order, then third side taken in reverse order will be their resultant, right? So if this is F1, this is F2, this side arrowhead, then if I reverse third one, then it will be minus F3. Then it is the resultant of the other two according to the triangle law. Then I can write F1 plus F2 equal to minus F3 according to triangle law. Then you can also write F1 plus F2 plus F3. See? Means this one. So when all the vectors are represented by sides of a triangle where all sides are taken in same order, sum of the vectors will be 0. Force is a vector, so it will obey this rule, and the sum of all these forces will be 0. Now tell me, if sum of all the forces are 0, then according to Newton's second law, F equal to ma. What is the acceleration of the body? 0, because net force 0, so there will be no acceleration. Then what is the changing velocity of the body? No change, because acceleration means changing velocity by time. So if acceleration is 0, no change in velocity will occur. So the body will continue to move along the same direction with same magnitude of velocity. Write it. Since some resultant of the forces are 0, resultant of all the forces is 0. Since resultant of all the forces is 0 in this problem, the acceleration of the mass will be 0 acceleration of the mass will be 0. So there will be no change in velocity. So there will be no change in velocity. Is it clear to everyone? Next problem. A force of 10 Newton, a force of 10 Newton is acting on a particle for 4 seconds. A force of 10 Newton is acting on a particle for 4 seconds along the direction of its velocity. Along the direction of its velocity. Means force and velocity are in the same direction. If the final velocity of the particle is 20 meter per second, 20 meter per second, then find the magnitude of change in momentum, change in linear momentum, change in linear momentum of the particle. Means initially velocity is something u, then it is changed to v, then change in linear momentum will be mv minus mu. So that linear momentum's change you have to find out. How can you make this one 10? Okay, F is given 10. Okay, V is given. But how U is so much? U is not given. Mass is not given. See how to find mv minus mu, that is the change in momentum. M into V means mass into final velocity, that is final momentum. M into U is mass into initial velocity, that is initial momentum. And now you prepare to calculate mv minus mu. Okay, but m is not there, u is not there. Then how to find? Without the value of m and u, can't we find? How? Force into time. Just write Newton's second law. F equal to ma. So since all are along the same line, I can write it scalar form without using vector. Then I can write F equal to m into v minus u by t. Then I can write F into t equal to mv minus mu. So do we require the value of m and u to calculate change in momentum? No, because I can directly find the product of force and time, which is equal to the change in momentum. So just write, this one is given how much? 10 Newton. This one is given 4 seconds. So mv minus mu, that is the change in momentum. That is mv minus mu equal to 40 Newton second. That is the change in momentum. So no need to search for m and u. By multiplying force into time, you can also find the change in momentum from Newton's second law.
That is impulse.
Impulse. That is called impulse. Yes. How? Is. अच्छा, you write impulse. Okay. You read. So force is given. How do you got acceleration? Velocity by. It is changing velocity, right? But u is not given. Acceleration means v minus u by t. So how can you consider u to be 0? It is not mentioned in the problem. Is it clear to everyone? So not that always you have to find mv minus mu. If it is given force and time product you are taking, then it is also changing momentum. That is called impulse. Now, suppose there is one block of mass, say 2 kg, and there is a bigger block of mass, say 8 kg. These are on a smooth horizontal surface. You are applying a force on this block, that is 20 Newton. This is 2 kg, small mass is 2 kg, bigger mass is 8 kg. You are applying a force horizontally on the 2 kg block that is 20 Newton. Okay? Find the forces exerted by the 2 kg block. Find the force exerted by 2 kg block on the 8 kg block. Find the force exerted by 2 kg block on 8 kg block. How much? 40. No. What is total force? 20. Then how much force is transferred by 2 kg block to the 8 kg block? It cannot be more than 20 Newton. Because force is supplied 20 Newton. So this force is divided into 2 parts. So if it is divided into 2 parts, then how on the 8 kg block force can increase beyond the original force?
So 16 Newton.
Correct. See, I can show you 2 methods to solve this problem. First one, I will show you the method which is bit longer but more conceptual. Second one is the method that you should apply in exam, because it will take small time to solve. See, first we think that we will draw each block independently. This one is a 2 kg mass. This one is a 8 kg mass. Okay. Now, what are the possible forces on 2 kg mass? Draw all possible forces. On this side, you are applying a force 20 Newton. On this side, there is a gravity, 2 into acceleration due to gravity. I write 2g, that is weight. On this direction, there is the normal reaction force by the ground. Okay? Now, whenever you push, this 2 kg block will exert a force on the 8 kg block. That is the force of the contact surface. So that is another normal reaction. That is also a normal reaction force, because when the surfaces are in contact, they pushing each other, then it is normal reaction. So normal reaction will not only come from the ground. Between the contact surface, between the block, there is also normal reaction force. Now, one such normal reaction is considered here, exerted by the 2 kg block, that is N. So if this block exerts a force N on this, then according to third law, this 8 kg block will return this one in the opposite direction, that is reaction. Done. Now we will draw all the forces on this block. 8 into weight and acceleration due to gravity. Normal reaction from the ground, that is N2. Is there any other force on the 8 kg block or 2 kg block? No, because surface is smooth, so no friction. So we draw all the forces. See, when you draw the free body diagram, never miss the forces. Otherwise it is difficult to solve the problem. So first, 20 Newton force is applied by us on the 2 kg block in a horizontal direction. Then 2 kg block will exert a force N on the contact surface of the 8 kg block. Then 8 kg block will exert the reaction on the 2 kg block in opposite direction of same magnitude. That's why it is also N. Then there is a reaction from the ground on the 2 kg block, that is denoted as N1. And earth pulls the 2 kg block downward with its weight, that is 2 into acceleration due to gravity. Then come to the 8 kg block. In 8 kg block, there is a force N exerted by 2 kg block. There is a normal reaction from the ground, that is N2, and weight of that block, that is 8 into G. So all the forces are drawn. Now think about it, in which direction acceleration occurs? In horizontal direction or in vertical direction? Horizontal direction. So neither of the block can move in vertical direction. So vertical forces are no more required to solve this problem. So though I draw all the forces, but now you can lift these forces. You can leave these forces because they are not at all in the direction of acceleration. Now, in which direction both the bodies will accelerate? Along this, because applied force is given from this direction. So all the bodies will accelerate along this. This body will also accelerate along this. Now can you tell me why accelerations are equal? It may have happened that A1 and A2. Why I consider acceleration are equal?
They are in contact.
Yes?
They are in contact.
They are in contact. Moreover, they are rigid. If they are in contact, if they lose contact, then 8 kg mass will not receive any force. So if they are 8 kg mass is receiving force from the 2 kg mass, then it must move with the same acceleration as that of the 2 kg mass. So both the masses are moving with equal acceleration. Clear? Now it is the time to draw the Newton and to write Newton's second law for each of the masses. So come to this first mass. In this direction of acceleration, what is the amount of force? 20 Newton. In the opposite direction, what is the force? N. Now which force is greater? 20 Newton, because net force will be in the direction of acceleration. Okay? So if 20 Newton is there, N is there, then this force must be higher. So I can write for this mass 20 minus normal reaction, that is equal to 2 kg into acceleration. Net force 20 minus normal reaction force, 20 minus normal reaction force equal to 2 into 8. That is resultant force equal to mass times acceleration as predicted by Newton's second law. Okay? Now, for that 8 kg mass, what is the force in the direction of acceleration? Only N. There is no other force in the direction of acceleration. So in Newton's law, F equal to ma, F is replaced by N. N. In place of F, you must write N. That is 8 into A. Force is N itself. This will be mass into acceleration. Here the force will be 20 minus N. That's why 20 minus N equal to mass into acceleration. In that case, N is the only external force. Then N equal to mass into acceleration. Okay. Is it clear to everyone? That net force first you have to calculate, then equate it with mass into acceleration. Now, solving this you can find n by eliminating a. So do it. From these two equations you have to find the value of n. How much it is coming? 16. N is coming 16. Just you have to divide this 20 minus n divided by n equal to 2a by 8a. I will divide this equation 1 and 2. 20 minus n by n. Left side is divided. Similarly, right side is divided equal to right side. That is 2a by a. 2, 4. Multiply. So it will be 40 minus 80. Sorry. 80 minus 4n equal to n. So 80 will be equal to 5n. So n is coming 16. I write the full name because already n is written here for normal reaction. So the force will be 16 Newton on the 8 kg mass. So the force that you are giving to the 2 kg mass, that is 20 Newton, from it only 16 Newton is transferred to the 8 kg mass. Okay. So this is the general technique to solve the problem such that you can verify what is going on between them. Whenever you push with 20 Newton, the 2 kg block will push the 8 Newton block with a force N. Then 8 kg block in turn will apply the same reaction on the 2 kg block in opposite direction. Then you write Newton's second law for two masses, solve it and find normal reaction force between the two blocks. Now, how to easily solve this problem? First, find out the acceleration. What is the net force? External force. Both the bodies together, take the masses together because they are moving with same acceleration. What is net force given? 20. So what is its acceleration? 20 divided by total mass. Force equal to mass into acceleration. So acceleration means force by mass. Force is 20. Total mass is 2 plus 8. That is 10. So what is acceleration? 2 meter per. Now, which block? What you have to calculate? Force between two block. Force between two block is N. Achha, on the 2 kg mass, how many forces are acting? Only N or N and 20 both? N and 20 both. So identify the mass on which only N acts. This one. So net force on this should be equal to mass of this object into that is your answer. Okay. So in the exam, use this technique. For understanding, when you are preparing at home, do all these things. Then, but in exam, don't do all these things. But for that, if you calculate this acceleration with this, that will not give you the N. Because 2 kg mass, only N is not acting. N is acting, another 20 Newton is acting. Then the force that you have to find, that is N. Then identify the object on which only N acts. only n acts on 8 kg. Then just multiply its mass with acceleration to find this n. Two kg block is subjected to two force. So if we calculate the mass of the 2 kg block into acceleration, then we are getting the resultant of 20 and n. But 8 kg block is subjected to only one force, that is n. So if I calculate the mass into acceleration for the 8 kg block, I get the value of it directly. One is between 5 kg and 3 kg, another is between 3 kg and 2 kg. In both the contact surfaces, the force has to be calculated. You can drop the vertical forces from the diagram because acceleration is only on the horizontal direction. So you may drop the vertical forces from the free body diagram. That is normal reaction from the ground and weight. This can be neglected.
Can
10 and 4. First one is from that, can apply either of the two methods that we have discussed in the first problem. Done? How much? Correct. First, go for the free body diagram. Though it's a long technique, but still it is the most basic, so go for the free body diagram. Five kg, three kg, and then 2 kg. Okay? Now what happens? You apply a force of 20 Newton from this side. So this 5 kg will push this 3 kg. So it will apply a force on 3 kg, let that be N1. So this 3 kg will also apply the reaction on the 5 kg. That is N1. Okay. Now, this 3 kg will push the 2 kg. Let that be N2. Then 2 kg will exert the reaction on the 3 kg. That is also N2. There is no other forces along the direction of acceleration. All the forces are drawn. You push this one with 20 Newton, this 5 kg will push 3 kg with N1, this 3 kg will in turn apply the reaction on the 5 kg, that is in the opposite direction, that is also N1. Then this 3 kg will exert a force N2 on the 2 kg, 2 kg will reply with the reaction N2, that is in the opposite direction, because action and reactions are always equal and opposite. Clear? So all the forces are drawn, which is along the direction of acceleration. Weight is downward, normal reaction from the ground is upward. They are not related to this acceleration, so we will not draw. All the bodies are in contact and they must move with same acceleration, because otherwise contact will lose and it will not receive the force. So this mass is accelerating along this mass is accelerating along this mass is accelerating along this. Now, come to this first 5 kg. This 20 Newton is along the direction of acceleration and N1 is opposite to the direction of acceleration. So what is the net force in the direction of acceleration? 20 minus N1, because 20 should be greater than N1 such that the body will accelerate along this. So it will be 20 minus N1 equal to 5A, mass into acceleration, according to Newton's second law. This is my equation 1. Then come to the 3 kg block. N1 is along the direction of acceleration, N2 is opposite to direction of acceleration. So what is net force? N1 minus N2. So write N1 minus N2. That is 3 into A. Okay? So this is my second equation. Now come to the last block. What is the only force? N2. So that will be equal to mass into acceleration, right? N2 equal to mass into acceleration. This is your equation 3. Now solve to find N1 and N2. 10 and 4. This method is a long method, but it will always lead you to the correct answer. Without any difficulty, you have to only write the Newton's law property, second law property, by completing the free body diagram. After that, I will show the shortcut technique. What? Oh. Okay. So after solving, whenever you try to solve this problem, first add the three equations. Add three equations directly. Then you will get the value of acceleration. Write it. First equation. 20 minus n1 equal to 5a. n1 minus n2 equal to 3a. n2 equal to 2a. Add all these three. What will happen? Minus n1 plus n1. Minus n2 plus n2. This side will be only 20. This side will be 10a. So acceleration is coming 2 meter per second square. Okay. Now put this value of acceleration in the third equation. You will get n2. So n2 will be 2 into 2, that is 4 Newton. Put the value of acceleration in third equation. Third equation is 2a. A is 2 meter per second square. So putting that, we can get 2 into 2, that is 4 Newton, because acceleration we have find 2 Newton, 2 meter per second square. Then put the value of n2 in put the value of a in first equation. You can find n1. Value of a is 2. Just put it in the first equation. You will get 20 minus n1 equal to 5 into 2, that is 10. So n1 will be 10 Newton. So after solving for a, I put the value of a in third equation and in first equation. From the third equation you will get the value of n2, and from the first equation you will get the value of n1. Okay, clear? Is it clear? Anyone having any question? Done? Okay. Now, how to find the answer without all these calculations? See. Can I erase this portion? What is the acceleration? Total force is 20. Total mass is 10. Then acceleration will be 20 by 10. That is 2 meter per second. Now see. can I draw like this? 5 kg, 3 kg together, and this one is 2 kg. N2, 20 Newton. So, which N1 is the block on which only N2 acts? 2 kg. So multiply that. So find the force on 2 kg, that is N2 will be equal to 2 kg mass into acceleration. 4 Newton. Now draw it separately. 5 kg is drawn alone. Three kg, 2 kg. Now, on this surface, what is the force? N1, reaction, N1. So, on which mass N1 is acting alone? Because on this mass there is 20 Newton also. So, N1 is acting alone on the 3 kg and 2 kg total. So, what is the total mass of this part? 5. So, N1 should be equal to 5 into acceleration. So first you have to consider 5 kg and 3 kg as a single mass and 2 kg as a different mass. Then you have to consider 5 kg as a single mass, 3 kg and 2 kg are combined. Then to calculate the reaction, normal reaction acting between this wall and this wall. So I have, in this situation, what we are doing actually, external force given by me is 20 Newton. So I will separate that object which is only feeling the normal reactions, not feeling the 20 Newton in this method. This one, these two together taken feeling 20 Newton and into, but this one is feeling only into. Now when I want to calculate this one, I separate like this. So this one is feeling 20 Newton and N1, and this total mass is feeling only N1, and then you can write mass into acceleration to calculate the force of the contact. Okay. So if this shortcut technique you can't apply, then directly go for the free body diagram, because that free body diagram technique, it may be little longer, but it will give you the proper answer without any difficulty. But in applying shortcut technique, sometimes which two blocks are taken together, which block is to left, that is a bit difficult. So you may not got it at the first when you are solving for the first time. So first try to apply the longer method but most conceptual method when you are practicing. Once you have a good amount of concept built, then try for the shortcuts. Then it will work. Yes, sir? 2 students. Okay. Okay. Is it clear to everyone? Now, so these are all the calculations of the force of contact between the two surfaces. Achha, this one is not a spring, this one is a rope. It has mass small n and pulled on this side by applying a constant force F on this side. This is a frictionless horizontal surface. This block A with which this rope is attached is capital M. Okay. Then if I ask you, what is the force with which the rope will pull the block? What is the force with which the rope will pull the block? I apply a force on the rope on this side, F, to pull the entire system. The question is, what is the force with which rope pulls the block?
F minus small m.
F minus
Small m.
small m.
G.
F is which direction? Horizontal. Mg is in vertical direction. So F minus Mg we cannot do. It is similar to the previous problem. Two masses are there and you apply a force, but now it is not pushing. Since string is attached, it can only pull. String cannot push. Again, I can show you the two methods. One is by free body diagram proper, another is the shortcut. How many masses are in this problem? 2. So separate these masses and draw the free body diagram first. There is a rope, mass, small m, and we apply a force, a constant force on this side to pull the entire system. What is the force with which this rope will pull the capital M? That we have to calculate. পুলিং ফোর্সটা শুধু একমাত্র কারণ কাজ করবে যারা গ্র্যাভিটি capital M F by sound. First thing, what is going on? How many masses are there? 2. So I will separate both the masses and draw it. This one is the rope. Now, this one is small m. Now tell me, what is the force applied by you on the rope? F. That pulling force on the rope on this side, that is F. When you pull it with a force F, the rope will pull the block with tension force, because rope can only apply, or string can only apply tension. String cannot, tension is always a pulling force, it cannot push. So on which direction string will pull this block? Along this direction with some tension. Now if the rope pulls the block with tension T, the block will also pull the rope because of hard lock. Action and reaction, equal and opposite. Rope will pull the block with tension T, then block will also pull the rope with same tension in opposite direction. Now draw it. In which direction entire system will accelerate? What will be the necessary condition for those accelerations to be same in magnitude? There must be one condition to be satisfied such that their accelerations will be same. Rope should be inextensible. It must not be elastic spring or like this. It should be inextensible, means its length should remain constant. In that case, acceleration of the block and the rope are equal. Clear? Whenever you solve the pulley problem, all times it is mentioned that rope is inextensible, such that you can take the acceleration magnitude same on either side of the pulley. Single mixed pulley problem. Now, for this mass, what is the equation of motion in second law? Only external force is T. T should be equal to mass into acceleration according to Newton's law, F equal to ma. So in place of F, I will write T, that should be equal to capital M into A. So this is your first equation for the block. Now for the rope, another mass, what are the two forces? F and T. Which force is in direction of acceleration? F. Opposite to acceleration? T. So what is the resultant force? F minus T. F minus T. This is the resultant force. This should be equated to mass into acceleration. Solve these two equations to find the value of T. Irrespective of A, answer should come because two unknown, T and A. So two equations, two unknown. You can completely solve. Okay. Now, can any one of you tell me the force T, is it greater than F or less than F? It is less than F. Why it is less than F? Means the force that you apply on the string cannot transfer the entire force to the block. Why?
Because the string has mass.
String has mass. Since string has mass, then to overcome the inertia, some force has to be used. That's why some less force T is transferred by the string to pull the block. Now, if string is massless, that is in pulley problem you face that the massless string, what will happen? In place of small m, you have to put 0. And if you put 0, then this one will be 0, m by n, then T should be equal to. So that's why for a massless string, on either side of the string or throughout the string, we draw the same tension. Because if string has mass, then from at different point of the string, tension force will be different. That will be more complicated. So for simplicity, we consider the massless string, and in massless string on every point tension remain same. Yes? Oh, we consider in the pulley problem massless string. Massless string means this rope is massless. Now see what happens. The force you apply here, if this small n is 0, then T equal to F means whatever be the tension here, the same tension will apply here. Massless means throughout the string, tension have the same value. That's why in pulley problem it is mentioned that the massless string is given. Because otherwise you cannot solve the problem. At different point, different tension will act, and it will be more complicated, and even complicated that you cannot apply Newton's law to solve this one. There are other methods to solve those problems. Here, now the shortcut technique without doing all this much calculation. Simple. What is the net force? External force F. What is the total mass? M plus M. So what is acceleration? On which mass you want to find the force? Block. So it will be mass of the block into acceleration of the block. Then you find the total force on the block, and that will be mf by m plus m. The same answer will come. First calculate acceleration, and after the calculation of acceleration you have to find the force of the block. So only force of the block is T. So that should be mass of the block into acceleration of the block. Okay, is it clear to everyone? The second technique. First we calculate acceleration. Acceleration means external force by total mass. What is the total mass? Capital M plus small m. So acceleration means total force by total mass. So we got the acceleration. Then on which object you have to find the force? Block. So what is the mass of the block? Capital M. Then force on this one will be mass of the block into acceleration of the block. Then I just multiply these two to get the answer. A is already calculated here, so multiply it with capital M. It will be mm by m plus n. Same result as before. But you can solve the problem in two lines. Okay. So first one we are considering a single fixed pulley problem as shown in the diagram. It is hanging from a ceiling. There are certain conditions. Write down the conditions one by one. First, one string is there. String is massless and inextensible. Massless and inextensible. Okay. Next, pulley wheel is massless. Pulley wheel is massless. Pulley wheel pulley wheel is massless. Number 3, pulley wheel, WHWL. Third point, there is no friction between string and wheel. There is no friction between string and wheel. Okay? Now, the rope will roll over the, now tell me, rope will roll over the pulley or it will slide over the pulley? It will slide over the pulley, because if there is sufficient friction, then it will roll over the pulley. Since there is no friction, it can only slide over the pulley. Clear? So in this situation, pulley will not rotate at all. If pulley wheel rotates and as a result string is not sliding, then like this, the friction is sufficient such that the contact point is always at rest, relative rest with that, like this. Is that contact point moving? No. But if it is going like this, the contact point is changing the position. It is in motion. So first we consider the frictionless, so it is only sliding motion over the wheel. The rope can only slide. Now each conditions that we consider in point number 1, 2, 3 has certain implications in writing the equation. So first, how many free body diagram we have to draw? 2, because there are 2 masses. So I can apply Newton's second law on each of the masses and write 2 equations. Then if I have 2 equations, then how many unknown variables should be there such that I can completely find 2? Because you know simultaneous linear equation in 2 variables, if there is 2 equations, only 2 unknown variables can be solved. If there are 2 equations and 3 or 4 variables unknown, then you cannot solve it. Clear? So number of unknown variables and number of equations must be equal for solving. So since there are 2 masses, I can apply Newton's second law twice for each of the mass and write 2 simultaneous linear equations. Then it must be that those simultaneous equations will contain only 2 unknown, not more than 2. If more than 2, then we cannot solve it by Newton's law. Clear? Now, first, try to draw the free body diagram or all the forces on this mass only. One is the gravitational pull of Earth, that is M1G. The string will pull the mass M1. With a force T. This mass is also pulled by Earth with a force M2G, and string will also pull this mass with same tension T. Clear? There is no other force, external force acting on this M1 and M2. Only these 2. One is their weight, another is the pulling force by string, that is tension. And tension can always pull on its either side. If you connect mass, it will pull both the masses, not that one is pulled and other is pushed. String has no ability to push, only it can pull. Now, come to the point. Why tension is same in magnitude in both sides? Because string is given mass less. So that condition is fulfilled. That's why I write T same on both sides. Now, which mass is heavier? M1. So this should come down with some acceleration. this should move up with same magnitude of acceleration. Magnitude of acceleration should be same. M1 is heavier, so it is going down. M2 is lighter, so it is going up. But acceleration's magnitude should be equal. Why they are equal? Property of the string is given inextensible. Inextensible. Clear? Another question I can ask. Okay, suppose there is friction, then what will happen to T1 and T2? What will happen to this tension? They will be different. Even if the string is massless, pulley and string if have friction, then T1 and T2 on these two sides will be different. So that's why I neglect the friction between pulley wheel and rope or string also, such that I can take the tension on both sides are equal in magnitude. Clear? Now you have to write Newton's second law for each of the masses. So tell me for M1 what is Newton's second law? First identify what is net force. In which direction M1 accelerates? Downward. So which force is greater, downward or upward? Downward force will be greater than the upward force. So resultant force will be M1G minus T. So for this mass M1 I can write M1G minus T. So M1G is more than T. So net force downward. So acceleration of M1 is downward. This should be equal to M1 into A according to second law. Done. First equation is written. Next, for M2, what is the equation? First identify the direction of acceleration. Upward. So which force is greater? Upward force. No, upward force should be greater. The direction of in the direction of acceleration, net force acts. So previously acceleration is in the downward direction. So downward force is greater than upward force. So we write M1G minus T. Now acceleration is in. So which force is greater? So resultant force will be T minus F. This should be M2 into A. Now your equation is complete. See, there are two unknowns. One is T, another is acceleration A. M1, M2, G. These are known quantities in a typical coding problem. Suppose M1 is given 5 kg, M2 is given 2 kg or 3 kg, and G is given 10. Then you can find tension and acceleration. Now solving. If I give M1 equal to 5 kg, M2 equal to 3 kg, and G equal to 10 meter per second square. Then calculate the tension and acceleration. Just in place of M1 you have to put 5. In place of M2 you have to put 3, and G should be 10. Calculate. What is the value of T and what is the value of A?
So A equal to 2.5. T equal to 15/4.
You have these two equations, just put the value of M1, M2 and G and solve. To find the value of T and E. Just two simultaneous linear equation you have to solve. from this you can write the formula for T and A, then you can substitute the value, or you can directly substitute the values here and solve it. So I will first directly substitute the value and solve it. M1 is given 5. So first equation can be written 5G means 50 minus T, that is equal to 5 into A. Okay. Second equation, T minus M to G. M2 is 3, so that is 30 equal to 3A. So first add these two equations. T will cancel. Plus T minus T, it will cancel. It will become 50 minus 30, that is 20 equal to 8A. So A will be equal to 2.5 meter per second square. A will be 2.5 meter per second square. 20 by 8. 20 by 8 means 10 by 4. 10 by 4 means 2.5. Which step? Which step you got? Mass is given M1 is given 5. G is 10. I will tell is 50 minus T will be equal to 5 into A. Similarly, second equation. M2 is given 3. CG is 10 into 3 is 30. T minus 30 will be equal to 3. Then we have two equations. 50 minus T equal to 5A. And then T minus 30 equal to 3. Add this two. Minus T is in the first equation, plus T is in the second. 50 minus 30 will be T. On the other side, 5A plus 3 will be 20 by 8 means 4 by 2. Value of A in either of the equation, 50 minus 2 or 50 minus 30. Okay. So we get the equation of value of acceleration. Now put this value of acceleration in either of these two equations. Any of these. You will get the value of T. That is, suppose I put here. So T minus 30 equal to 3 into 2.5. So that will be T minus 30 equal to 3 into 2.5 means 7.5. So T will be equal to 30 plus 7.5 means 37.5 Newton. So T will be 37.5 Newton and acceleration will be 2.5 meter per second square. Okay. Now, all of you understand? So, main thing is that you have to complete the free body diagram and write the Newton's second for each masses. After that, it is just a simultaneous equation solving, nothing else. But the main concept lies in writing the Newton's law and completing the free body diagram without missing a single force. Because if you miss a single force, your equation will be wrong. Clear? Now, again it is given that M1 is greater than M2. But now M1 is on a table and the table is perfectly smooth. Table is perfectly smooth. M1 is placed on the table. Now what is the need to write the Newton's equation of second law for both the masses as before. First identify all the forces on each mass, then write Newton's second law for each of the mass. The two equations that I write for the previous problem, similarly you can write two equations for this problem, then we will proceed further. First complete up to that. Oh, this is the table. It is 1/4. No. M1 mass is on a table and M2 is hanging. And they are connected by a inextensible massless string and there is no friction, and that means all the ideal conditions are given. That is, pulley is massless, there is no friction between pulley, wheel and string, there is no friction between table and M1. All these things are given. So table surface is smooth perfectly. String is inextensible, massless, all these are given. Now you have to write only the equations for M1 and M2. Previously both the masses are hanging, now one mass is over a table, another mass is hanging. First try to draw the free body diagram. Previous equation and this equation is something different. M1 is now on a table. Previously M1 was also hanging. Now M1 is table. So some situation will change. Tension is around. Tension can always be done. For this tension resistance is taken down. Supply this mass with the acceleration. Because there is no fundamental friction. Even if it is more heavier, it cannot accelerate down. It can stop the acceleration if there is some friction to prevent the tension. This is more. So even if it is so much heavier, still it will slide. Yes. When we can simply minus the magnitude, then the forces are along the same direction. R and K and P along the same direction.
motion will be, but that is not helping the accelerator. Acceleration is not helping these forces are vertical. So we need to take this into account.
See, first we draw all the forces, external forces on the masses, and then we further analyze. Check. On this mass, there is a force m2g due to Earth's gravitational pull, that is weight. There is tension T. Okay, tension is pulling it. Now on this mass, there is a force m1g. There is a force normal reaction, suppose N1, and string is also pulling it. String can never push, so string will pull masses connected to its either end. Now, tell me in which direction the system will accelerate. M2 will move down or up.
Downward.
So who said upward? If you are saying upward because of this equation that M1 is greater than M2, then I will ask you, if it is moving upward, this M1 will move with acceleration around this, then you must tell me what is the force which is pulling the mass M1 with acceleration. Without force, how can it be accelerated in that direction? So heavier mass means it will move on that direction. That is not true. Heavier mass should be pulled. Some force should be there. So there is no force on this M1 along this. So it will never accelerate along this. Now it will accelerate along this, and it will accelerate along this. Now you may have one question that, sir, you write M1 is greater than M2, then okay, fine, M1 cannot accelerate on that direction, but can it happen that both the bodies are at rest? Because M1 is heavier, so M2 is very small mass, so it cannot be capable of pulling M1 to that. In that situation, acceleration will be. Then you must tell me that which force is pulling M1 to this side? T. So there must be some force exactly equal and opposite to T. Is there any force? Friction is not there. Even if there is sufficient friction on this table, then friction can prevent this T, and it may happen that this system is at rest. Otherwise, whatever be its mass and whatever be small its mass, it will only accelerate on this side and it will move to the right. There should be friction to stop the movement, and by no means it can move on its own on that side. Clear? Now, since there is no friction, so there is no question of no movement. There is only movement, so it will accelerate out, it will accelerate on this side. Both the accelerations have same magnitude because string is still inextensible. Clear? Tensions are same because massless string is provided, there is no friction. So tensions on the both sides of the string are equal, accelerations are of equal magnitude. Now we have to write the Newton's second law for each of the mass. Free body diagram is complete. No more force is there. Now, tell me for mass M2, what is free body diagram? What is the equation of motion from Newton's second law? M2g minus t. Because always remember, acceleration is in which direction? That direction force is more. So you have to subtract this force minus this force, not the opposite. So that is M2g minus t equal to M2a. Done. What is the equation for M1?
T equal to M1.
Again?
T equal to M1.
T equal to
M1.
Only T equal to M1. Other two forces,
M1 is
all these things should come? Definitely not. T should be equal to M1A. See, first we will draw all the forces. All the external forces on individual masses we will draw, because that is the first step to apply Newton's law. Clear? First draw all the forces. Suppose on M, what are the forces? Achha, can I write this one as M1 or M2 and this one as M1? And we considered that M2 equal to 3 kg and M1 equal to 6 kg, the same. But the name is changed because either 2M, 2M, all these things are not written, M2 and M1. I write. M2 is given 3 and M1 is 6. That is, if M2 is written as M, M1 is written as 2M. Now, draw all the forces, external forces. M2G is 1. Tension in the upward direction, that is 1. Is there any other external force acting on M2? No, because it is not in contact with the wall or anything. There is no, only two forces. One is weight, another is tension force. So these are the two external forces acting on M2 only. There is no other external force. Complete. Now, what are the external forces on M1? Draw. First one is gravity. Acting vertically downward. Vertically downward, remember. String will pull, so there will be a tension along this direction. That is T. The surface will exert a normal reaction, that is N1. Is there any other external force on N1? Tension is there for the string. Earth will pull with weight. Surface, inclined surface will exert normal reaction. There is no other external force on this. Clear? Now, in which direction? But before solving, you don't know what is the acceleration value and what is the direction of acceleration. Now, what you will do? It may accelerate on this side, it may accelerate on this side. You cannot say that this is heavier mass, so this will accelerate on this side, because that is on the inclined plane and it is vertically hanging. So it may happen that the effect of the inclination, due to effect of the inclination, this mass will move down, this mass will move up. So in this situation, what we will do? We will simply consider any direction for the acceleration. That is my wish. Suppose I consider that this mass is moving down with the acceleration A. Then this mass should move up with acceleration A. Now, we don't know in which direction it actually accelerates. Suppose it is actually accelerating, that M1 is going down and M2 is moving up, then our choice will be opposite. So what we will do? Should we cancel the problem and solve it again by considering the other direction of acceleration? That much time is not available. We will solve it. If the acceleration value comes to be positive, that means the acceleration that we consider, it is in the same direction. And if it comes negative, then we call the actual acceleration is in the opposite direction that we have considered, because acceleration is a vector quantity. So negative sign comes means you don't have to cancel the problem once again, don't cancel the problem and then do it again. Cancelling the problem, you will do it again, that is not a solution. Just write acceleration is negative, means original acceleration will be opposite that we considered. Clear? Now, suppose in this case we consider acceleration in this direction, this one will move on. It is very easy to write the equation of motion for this m2, right? What is the equation of motion? m2g minus t, that is equal to m2a, because acceleration is downward, so net force should be downward. Net force will be m2g minus t, their resultant. So write it, m2g minus t equal to m2e. Now, what about m1? See, acceleration is along the incline, upward. Which force is along the incline? Only t. Other two forces are not along the incline. So, are they having any effect on the acceleration? Which one has effect? Weight has effect, but normal reaction has no effect, because normal reaction is perpendicular to the direction of acceleration. But m1g is not along acceleration, but not perpendicular to the acceleration also. So it has some effect, not the complete effect. Now, some part of the effect, how can it be calculated? By taking component. It has some effect, because if it is exactly aligned as t with the acceleration, then it has the complete effect on the acceleration. If it is perpendicular like n1, then it has no effect. But if it is neither perpendicular not along the direction, then it has some effect, not the complete effect, partial effect. Then partial effect should be calculated from component calculation. How we will do it? I can resolve m1g into two components. One is vertical, perpendicular to the incline, another is along the incline. Draw this, complete this diagram. Two components. You know that if this angle is theta, this angle should be theta. How many of you know? Raise your hand. Others don't know. If that angle is theta, how that angle be theta? Okay? See how. Just draw this line up to this. This one will be 90 degree. So what is the value of this one? Theta. So what is the value of this angle? 90 degree minus theta. Then these two are perpendicular. What is the value of this entire angle? So this part is 90 minus theta. So the remaining part should be just this line of m1g, intersect it up to the base. This is right angle, this is theta. So this part will be 90 minus theta. Now since you are drawing this line perpendicular to the incline, then this total angle is theta. So if a part of it is 90 minus theta, then other part should be theta only. Okay? So I will erase this things. This one is m1g. Now this angle is theta. Now the adjacent component is taken as cos theta, and the other component is taken as sin theta, that we have already done in trigonometry. So I will write this component as m1g cos theta, and this component as m1g sin theta. If you have difficulty, you can complete this triangle and verify. With respect to this one, this side is hypotenuse m1g, this side is base. Base by hypotenuse is cosine theta. So this will be m1g cosine theta. This part is perpendicular, so it will be sine theta. So it will be m1g sine theta. Now if this is m1g sine theta, use the parallelogram rule. You can draw it here. That is m1g sine theta. So a force is divided into two parts. Adjacent component to theta is called cosine theta. The other component is called mg sine theta. Okay. Now see, why n1 cannot have any effect on acceleration? Because it is perpendicular to acceleration. Now similarly, m1g is also perpendicular to acceleration. So it has no effect on acceleration. Any vector, if it is perpendicular, then it has no effect on its 90-degree direction. So n1 is here, perpendicular to the direction of acceleration. So n1 will not affect this acceleration. Similarly, now m1g is also perpendicular to acceleration of m1, so it will not affect the acceleration of m1. Now which part will affect the acceleration of m1? This will try to slow down the acceleration. Okay. Now, then for this acceleration of m1, which two forces we will consider? Then write Newton's second law. Net force should be along the direction of acceleration. So what is the net force? T minus m1g sine theta. Because the net force should be along direction of acceleration. That you have written. A. For this one, how write? m2g minus t. Then for this acceleration direction, force is more. So t minus the force in the opposite direction, m1g sine theta. So write t minus m1g sine theta equal to m1e. Now your two equations are complete. Now you can solve. Resolution you have to learn very carefully, because otherwise inclined and all these problems will require the good concept of resolution of the forces. But previous problems are easy because there is no such resolution or all these things. You can directly apply. Okay, now put the values and solve. From first equation we can write t minus, what is m1? 6. So that is 6 into g. 6g means 60. Sine 30 means half. Equal to 6a. So this equation is reduced to t minus 30 equal to 6a. This is coming from equation 1. T minus 30 equal to 6a. Why? Because m1 is given 6, g is given 10, sine 30 will be half. So it will be 60 by 30, 60 by half. 60 into 1 by 2, that is 30. So t minus 30 will be 6a. This is the first equation. Now second equation. M2 is given 3, so 3 into g means 30 minus t, that is coming 3a. This is my second equation. Add these two. Plus t minus t, plus minus 30 plus 30. So a will become 0. means the masses will not move in either way. Acceleration will become 0. And now put the value of acceleration in any of the equation. Suppose in equation 2 I put, then we get T equal to 30 Newton. T will be equal to 30 Newton, then acceleration 0.